All right, here we go. Fifth and final page of this review. Let's see what we got here. I'm launching some rockets. Launching a model rocket into the air, and I am 100 feet from the launch pad. The angle of elevation is 62 degrees. How high up does the rocket go? All right, so here I am. All right, here's me. And I am standing 100 feet from our launch pad. All right, so this rocket goes up. It's going up somewhere. Or maybe it goes up this high. So I have to look at an angle of elevation of 72 degrees. So that is our angle of elevation right here, 72. And no, it's not to scale, but get over it. 72 degrees. All right. They want to know how high up the rocket goes. Now, keep in mind for this problem, right? That is the height. That is the that's what we need to look for. So I am a certain height. So we'll just put H here. I don't know how tall I am. We're going to find H in this problem. I'm sorry, we're going to find X in this problem. Now, I know I'm 100 feet from this launch pad. All right, so what we have is using the 72-degree angle as our reference angle. We are looking for the opposite. We have the adjacent, so that leaves us with the tangent. So the tangent of 72, all right, tangent of 72 equals opposite, which is X, over the adjacent, which is 100. All right, so typing all of that into our calculator, we're going to have, so we need to solve. So here, let's do this. 100 times the tangent, 100 times the tangent of 72 equals X. All right, and that's what we need to type into our calculator. Come on. All right, we're going to have 100 times the tangent of 72. Close up that parenthesis, and that's going to give us 307. All right, so this rocket, so X is 307. All right, now keep in mind how high it went up, how the height of the rocket. Height of rocket. All right, that's going to equal X plus H, right? So it's going to be like my eyeballs to the ground, right? Because I'm not measuring, I'm not like getting on my stomach and looking up at this thing. I'm standing up. And the angle of elevation from my eyes to the rocket was 72. All right, so the height of the rocket is X plus H, or 307 feet plus however tall I am. All right, next. Pilot is in an airplane. He's looking out the window to a runway. Most commercial airlines fly an altitude of 30,000 feet. The angle of depression, all right, 34 degrees. What is the horizontal distance to the runway? We need to be very careful about this. When there's a similar question on the tests. All right, so there we go. There's our triangle. The altitude, all right, that's, excuse me. It's pretty straightforward. That's how high up in the air the plane is. So this is our 30,000. My stylus is not cooperating here. All right, 30,000. Here's our plane. Our plane is up here. Now, the pilot, he's looking down. So the angle of depression. Keep in mind, the angle of depression is the horizon line, right? He's looking straight off into the horizon. How many degrees does he have to tilt his head down? So the angle of depression is 34. All right, a lot of people, don't let this be you. A lot of people are going to put the 34 right there. All right, don't do that. All right, so the 34, it needs to go in the top one. All right, and keep in mind, we know the angle of depression and the angle of elevation, they both use the horizon. The horizon is parallel, or it's pretty close to being parallel, so it's good enough for application problems. All right, so we have that 34-degree angle. That's also the angle of elevation. And what are we trying to find? The horizontal distance from the runway. So we're looking for x. All right, so this is just another tangent problem. So the tangent with the opposite and the adjacent. So the tangent of 34, tangent of 34 is 30,000, opposite 30,000 over the adjacent. All right, so do a little bit of algebra. I'll leave that part to you, and we're going to get x equals 30k over the tangent of 34. All right, we solve that. We plug that into the calculator. 30,000, right, divided by the tangent of 34. That's going to give us 44,476 and some change. What do we got here? And 0.83. 0.83. So that's our horizontal distance. All right, next one. Oh yeah, this one. Okay. This one is going to require a little bit of thinking on how to. I'm going to put myself somewhere. We're going down here. All right. This one is going to require just a little bit of thought. All right. So a mountain climber, he's standing between two mountain peaks. All right. So mountain climber is right here. All right. And we have, one mountain range over here, and we have another mountain range, elsewhere. All right. So here's what we're going to do. I'm going to shrink this guy down to a point. All right. So he's right here. The mountain to the west is 20,000 feet tall. Okay, so this right here is 12,000 feet. Right. He needs to look at an angle of elevation of 47 degrees. All right, now the mountain to the east is 17,000 feet tall. All right, so this one's a little bit taller. Right, 17,000 feet. All right, and for this one, he has to look at a angle of elevation that's 64 degrees. What they want to know is which mountain is he closer to. All right, so we're not talking about the hypotenuse. We're not talking about his eye to the top of the mountain. We're talking about how far away is he from the base of the mountain. All right, let's say like the center of the mountain. I don't know how wide these mountains are, whatever. So what we need to do is we need to figure out x and we need to figure out y. All right, so let's do the red one first. So we know the tangent of 47. That was supposed to be red. Let's try that again. The tangent of 47. Tangent of 47 is going to be equal to, let's see, opposite over adjacent, 12,000 over x. All right, therefore, x equals 12,000. 12,000 divided by the tangent of 47. All right, I don't know what that is, so let's go to the calculator. 12,000. 12,000 divided by the tangent of 47. All right, so that is, let's go 11,000. So x equals, let's see, 11190. So x equals 11190. All right, so now let's try it again with the blue mountain. All right, so we know the blue mountain, we got the tangent. So very similar, the tangent of 64 now. Let's see, that's gonna be 17,000 over y. Right, so y is equal to 17,000 over the tangent of 64. All right, so we got 17,000 divided by tangent of 64, which is 8,291. So y equals 8,291. So, all right, this should be pretty clear. Which mountain is he closer to? Well, What do you think? Should we take a bigger number or a smaller number? All right, so he's closer to y. Closer to the east mountain. It's closer to the eastern mountain. All right. Last and not least, Aaron and Erica. What are these two up to? Aaron and Erica are standing at the seashore 10 miles apart. All right. Coastline is a straight line between them. All right. So I think we had a very similar homework problem. All right. So let's see here. We have we're saying Aaron is over here. So, and Erica. Oh man, that was a bad choice. We'll start with an E. All right. Erica and Aaron, they're standing 10 miles apart. So we know this is 10. All right. The coastline is a straight line between them. Both can see the same ship in the water. Okay, so there's a ship somewhere out here. It's not right in the middle. We don't know that. I mean, it could be right in the middle, but we don't know. So maybe it's right there. So let's do one of these. All right, so let's say this one's Aaron. All right, this one's Erica. These were my cadet teachers 2 years ago. Aaron and Erica, 10 miles apart. The coastline is a straight line between them. Both can see the same ship in the water. The angle of the coastline between Aaron is 35 degrees. So this is going to be a 35-degree angle. The angle between the coastline and the line between the ship and Erica is 45 degrees. All right. How far is the ship from Aaron? All right. So sorry, Erica, but we don't really care how far away the ship is from you. We want to know how far away it is from Aaron. So what do we have to do? This is going to be a law of sines problem. All right. And I know that because this angle right here, it's not a 90-degree angle, right? So let's see, we have 35 plus 45, that gives us 50. So these two are 80 together. So that leaves this with a 100-degree angle. Now, law of sines or the law of cosines. So keep in mind, for the law of cosines, we need to know all three sides, or we need to be able to use at least two of the three sides. All right. I have no idea how far the boat is from Erica, so we can't just use that number. So what we're going to have to end up doing on this one is the law of sines. All right. So we know that angle between the boat and, opposite to the shore. We know Erica's angle, and we know well, we don't know, but we're looking for the distance between Aaron and the boat, which in this case we call the X. All right. So here's what we do. Here's our law of sines setup. We're going to have the sine of 45. Sine of 45 divided by X is going to be equal to the sine of 100 divided by 10. All right. What do we do? Cross multiply. So we got X. You guys should be experts at the law of sines by now. Sine of 100 equals 10 times the sine of 45. All right. So X. So now from here, a lot of people, when we get to this point, I've had a handful of people ask me, do we divide the 10 over? Do we divide the sine of 45 over? Do we divide the sine of 100? Which one is it? Well, keep in mind, we're trying to get X by itself. So there's no reason to move X to the right side. What we need to do is we need to move the sine. We're trying to get X by itself. So let's get rid of that sine of 100. Sine of 100, divide that on both sides. All right, so we're going to get X equals 10 times the sine of 45 divided by the sine of 100. All right, let's type that into our calculator. What's that going to give us? 10 times the sine of 45 divided by the sine of 100 equals 7.18. 7.18. So this boat is 7.18 miles away from Erin. All right. And that's how we do this problem. All right. And that's how we do the review packet. And that's how we do Unit 7. All right. Thanks for watching, and we'll see you guys in class.